All right, today we're going to be looking at simplifying our radical expressions. Our radical expressions today are going to have a lot of variables in them as well as just numbers. So looking at our first one here, we have 144 times y to the second power. Well, we can rewrite this and think about this as 144 is 12 times 12, and this one's y times y. So I have pairs, and if you have pairs under the radical, we can pull them outside the radical. This is 12. This pair right here comes out as a y. So that would be my final answer, actually, for this one would be 12y. It's like we're taking the square root of each individual piece. Also, we can think of these things, though, because it's going to get kind of confusing, especially if we get variables with the exponents that are really large. We don't want to have to write out all of them like this and go collect the pairs. So looking at example 2 here, think of it like this. I'm doing the square root of 81, each piece individually, square root of a to the 4th, square root of b to the 6th, square root of c to the 10th. Well, square root of 81. Square root of 81 is 9, because 9 times 9 makes 81. When I'm taking care of my variables, I'm going to basically go through and divide my exponent by 2. So here I have a to the 4th power. Well, now it's going to translate to a to the 2nd power, because 4 divided by 2 is 2. My b is going to be b to the 3rd power, because 6 divided by 2 is 3. And c is going to be c to the 5th power. And there would be our final simplified answer. Looking here at number 3, well, 24 is not a perfect square. We can go through and divide this up into our pairs, or we can start thinking, what's a perfect square that goes into 24? Well, I know 4 does, so 4 times 6 is a perfect square. And then I can rewrite my x to the 5th power as x to the 4th times x. So now when I deal with this, I have the square root of 4 times the square root of 6 times the square root of x to the 4th times the square root of x. Well, this one right here, square root of 4, that's 2. Square root of x to the 4th power would be x squared. These two pieces here get left under the radical, and I can write them under one radical. So it'll be 6x. And that would be our final answer for that one. Looking here at number 4, I can rewrite this thing as 3 times 25, because I know 25 is a perfect square and goes into 75 evenly, goes 3 times. I have my x squared, and then I have y squared and a y. So I go here and think about it and say, square root of 25. Square root of 25 is 5, so I'm going to put a 5. This part's been taken care of. Can't do anything to the 3. Oh, I got an x squared. Take care of my x squared. I divide the exponent by 2. So that just gives me an x to the 1st power. That part's been taken care of. I have another variable with an even numbered exponent. That's a y squared. So 2 divided by 1 is 1. So I have y to the 1st power, and that one's been taken care of. Nothing else can become outside of my radical. So the 3 stays in, and I have a y to the 1st power left in. And at this point, we would be done with that. Okay, looking at another example here, number 5, I have 161, the square root of 162, sorry, times a times b to the 6th, b to the 5th. 162. Well, if I divide that by 2, I have the square root of 2 times 81 I have an a, b to the 6th. My c I'm going to split apart, so it's c to the 4th and c, because I need to make sure I have it. If it's larger than 2, I need to have an even portion of it. Here I go through and collect the first thing. Oh, here's the first thing that's a perfect square, 81. So I come over here and say the square root of 81 is 9. So my 81 is gone. Can't do anything to the a, b to the 6th power. That's a perfect square. So this is now going to become b. 6 divided by 2 is 3. So b to the 3rd power. Next I have c to the 4th power. That's a perfect square again. So that now becomes c to the, well, 4 divided by 2 is 2. So it's c to the 2nd power. And now that part is gone. I have some stuff left inside the radical. I have a 2ac. So the simplified form for number 5 would be 9b to the 3rd, c to the 2nd, square root of 2ac. Looking here at number 6, well, number 6, it has a number on the outside. It has this 3. Well, this 3 is just going to be coming along for the ride. Okay? So he's going to be chilling out front here. 121 is already a perfect square, so we're going to leave it alone for a second. I have my m to the 4th is a perfect square. N I need to separate to n to the 4th and an n to the 1st. And then here I have p to the 6th and p. So now whenever I come down to my next level here, I'm going to take and have 3 times, well, the square root of 121 is 11. We're done with that portion. I have here m to the 4th power, so that becomes m to the 2nd power. We divide the 4 by 2. Next I have n to the 4th power, so that becomes n to the 2nd power. Again, divide the 4 by 2, our exponent by 2. Can't do anything with my n to the 1st power. Oh, here's p to the 6th power, another perfect square. So this becomes p to the 3rd power. 6 divided by 2 is 3. I have some stuff left inside my radical. I have an n and a p. I now have to go through and multiply 3 times 11, which is 33. I have my m squared, n squared, p to the 3rd, square root of np. And that would be our final answer. And the last one we're going to look at today, we're going to look at number 7 here. Again, the 5 on the front. He's just going to be chilling out front until we get done with everything in the radical. So I have the negative 5. The stuff inside my radical, this is going to be 2 times 36, because 36 is a perfect square. This is going to be x to the 4th times x. That gives me 5 of them, but I need to break part of it off into its perfect square form. And then I have y to the 4th. So here, my 5 just comes down for the ride, times whatever might come out. Here I have a 36. Well, the square root of 36 is going to be 6. So it comes out, and I'm done with that portion. Next I have x to the 4th. Well, I can take part of that out of there. That becomes x squared. So we divide our exponents by 2. We're done with that portion. Can't do anything. X to the 1st power. Y to the 4th power. That's another perfect square. So that gives me y to the 2nd power. I do have stuff left inside the radical. I have 2, and I have x. I now have to multiply. So my final answer would be negative 30, x squared, y squared, times the square root of 2x. I'm going to go through and find the pieces underneath the radical that are perfect squares, whether it be with the number or with our variables. Pay attention to what you're doing, and as always, good luck with all you do.